Hello, everyone. Chris here with another FreeCAD stream. Going to be finishing off this machine Vise that we started in the last stream. The funny thing, I actually was looking looking up some information, mostly related to this tapered pin here, because I wasn't sure what that was the last time. And while I was researching that, I happened to discover that there are actually several people who have modeled this exact same machine Vice here, and there's I'm sure models you could probably go download, but this textbook page actually showed up in the Google image search and whatnot. So, but downloading those models doesn't necessarily teach you to how to create this. So that's what I'm going to go through here on this. The last two pieces we had here were this base and the jaw down here. So I think what I'm actually going to do is start with the jaw down here. I think it's perhaps a little bit simpler. And yeah, so let's see here. So let's create a new document. Again, we're going to create a part and create a body within the part. And I mentioned in the last stream that I create a part before creating the body. You don't necessarily have to do this, but given that we're going to be using assembly 3 later, when I put all this together into an assembly, I'm going to, or having this as a part makes it a little bit easier to insert it into those assemblies. Um, so what I'm going to do here is I'm going to rename the part to match, let's see, it's number 2. So I'm going to rename this to be 2 dash sliding jaw. And then we're just going to save the document into my FreeCAD machine Vice 2 dash sliding. All right, let's turn on the planes here. Now let's take a look at this part. So looking at this here, there's a few different ways you could go about this. It's mostly choosing which way you want to extrude and how many features you want to use to create this. I mean, I could see coming in here and drawing this outer profile and having it come all the way down and extruding it this direction. I could also see coming in and drawing just this upper profile, extruding it to full width, and then coming in and doing this lower profile here. So I think what I'm actually going to do is I'm just going to draw this side profile here and extrude it, and then I'm going to do the lower profile. And the one thing I'll mention here, I'm going to, in terms of choosing what my datum planes are going to be for starting this, I think that I'm going to let this surface here be, say, the XY plane, and I'm going to let the surface that forms the back side of the jaw here be, we'll just say, the YZ plane. And the reason so that kind of puts the origin, I'll put the origin over here. Oh wait, no, that wouldn't actually work. Scratch that. The origin will have to end up being over here. And the reason I'm doing that is because those two surfaces are in the finished part would be machined surfaces. And so they're kind of datum surfaces in general, or important surfaces. I could also choose to use the bottom down here instead of this one, but I'm just going to use these and the surface and what would be the backside surface here. So let's just get started. So I'm going to choose the XZ plane, create a sketch. Let's take a look at that again here. So I need to kind of draw roughly this side profile here. So we're going to polyline. And here, up, over, and then I'm just going to draw a 3-point arc between the two. And we're not worried about the dimensions here so much just yet. Just kind of want the general shape. Let's see what the actual dimensions are. And again, you'll have to forgive that this is all done in imperial units and this 1974 textbook. So the dimensions don't necessarily matter, the numbers themselves. It's more about how we're going to model this. So this is 1 inch and 9/16. So let's apply a horizontal dimension here. That's 1.5625. I just happen to know that decimal equivalent. Then the height of that is 1 3/4. .75. You'll notice that now the arc here is moving around because I haven't defined its radius. So let's just do that. So 1.375 radius. And then I believe it says here that, okay, so the center of the arc is 1/8 of an inch off that face and 1 3/16 down from the top. So I'm going to dimension it just like that. So pick that point, and this is 1/8. And then we're going to do a vertical dimension from there to there, which is 1.1875. So let's clean these up here just a little bit. Make it a little easier to read. And lastly, we have this over here, which is, let's see, that's 3/4 of an inch tall right there. So we're going to define vertical dimension here of 0.75. And now you see that the sketch is fully constrained, which is good. Right in here, you might notice I'm not putting these fillets in here. And I'm doing that because I'm going to end up just using the fillet tool later. Like there's a 1/4 inch radius there. And I guess there's maybe not a radius up here at the top. Maybe there actually, it's a little hard to tell from this. Maybe you can tell. Nope, it's just a sharp edge up there at the top. Okay. So I believe I have everything I need here. So now we're going to extrude this, and I am going to end up extruding it symmetrically from the center plane here. So I'm just going to close that. And now we need to do a pad. We need to make it symmetric. And as far as the width goes, I can just add all these numbers up here. I have 7/8 on this side, 7/8 on this side, plus this 0.997 in the middle. So if I come back over here to FreeCAD, I can type in 0.875 plus 0.875 plus 0.997. Hit enter and hit OK. So now we have the upper part of the jaw here. And now the next thing we want to do is we want to do this lower part of the jaw. So what I'm actually going to do is I'm going to pick this back surface as my sketching plane. I say create sketch. Now let's go in here and draw that general shape. Yeah, I'm not worrying about dimensions right away. Not worried that all these aren't perfectly constrained, or it didn't do the automatic constraints. So do a vertical there, do a vertical there, make this horizontal, make this line horizontal, and this line vertical. And so now I know that this part is symmetric about the vertical axis. So we're just going to go in here and we're going to make this point and this point symmetric about that vertical axis. Then I know that these two edges are symmetric about the vertical axis as well. So I could actually come in here and there's a couple of different ways you could do this. You could pick these 2 points and the central axis here, say that they're symmetric. The other way I could have done that, just undo, I could have made these two equal to each other, and then I could have said this point on this line, and that will also get you the same result there as them being symmetric. That just takes 2 constraints instead of 1, but that's okay. And there's multiple ways of doing this, so we're just going to undo that, and we're going to go back to making them symmetric. And then we want this line and this line to be kind of collinear with each other. So I'm going to, there's a couple ways you could do that. You could pick these 2 lines and say that they're equal, and that will take care of that for you. I could have also said this point and this line and said the coincident constraint as well. But we're just going to, we're going to go with the equals right there. And then lastly, we want this point and this line to be coincident. Oh, see. Oh, I accidentally had 3 things selected. It's okay. FreeCAD let us know. So we're also going to make that point and that line coincident. So now this is, everything is symmetric, things are equal what they need to be. And now I'm just going to put this point on this line. And now we can start applying some dimensions. Let's look at how it's dimensioned. So they give us a dimension down from the surface here. It's about, I guess, 50.5055. They give us a total height of 1.5 inches here. Then they give us the height of the slot, and then they give us the depth of the slot. Okay, this is that 0.218 right here. It's a little hard to read. They get the little arrow pointing to that gap. So let's dimension this the way that they have it dimensioned. So we want to do the overall height. The 1.5. They give us this height, which I don't remember what it was, so I'm not going to type it in. We can always go back and change it. And then we're going to do a vertical dimension from here to here of 0.188, I think. And then they gave us this, which I think is 0.218. Oh, this was 0.5055, I think. 0.5055. And then lastly, I guess the width of this. So we're just going to do a horizontal dimension here, which I think was 0.997. Let's go back and look at the image here. Yeah, 0.997 wide there. Then 0.5055, 0.1875 to be exact, 0.1875, and 0.218, 1.5 inches. Okay, so now we have that sketch fully constrained, and we're going to extrude it out here, this 2 9/16 dimension. We're not going to worry about this this angled surface here just yet. We'll do that next. So close the sketch. Now let's extrude it with the pad. Oh, it's going the wrong way. Reverse it. 2.5625 and hit OK. And now you can see we have that lower part. I'm actually going to go ahead and save real quick. All right, so now the next thing we need to do is we need to cut this angled surface here on the front. So we're going to do that with an extrude. I'm going to pick the XZ plane to create my sketch. I'm going to come in here and draw a triangle. I'm just going to draw the triangle. Okay, so it automatically applied the horizontal and vertical constraints there. And now we need to tie it to our geometry that we created before. So what I'm actually going to do is rotate just a little bit here. And we know that like this point is going to be in a certain distance from this corner. We know that this point falls on this corner. So we need to tie that geometry to the point where it starts. So we're just going to come up here, go add external geometry, and I'm going to pick this edge, and I'm actually going to pick this upper edge, and you can see it creates the reference geometry on our sketch. Let's go back to viewing the sketch. And now I can do a case of the points. We want a coincident constraint. So we'll pick this point and that point. And then we'll do this point and this point. And you'll notice here, FreeCAD is giving me the warning that I have redundant constraints. And that is because by making this point and this point coincident and these 2 points coincident up here, that automatically makes that line vertical. So I can delete the vertical constraint if I select it, hit delete. Now see it, that line is kind of a lighter green, meaning that it's fully constrained, but the whole sketch isn't. If it was dark green, it would be the whole sketch is fully constrained, but it's kind of lighter. So now I just need to apply a horizontal dimension to this, which I think that was 0.375. Let's double check. Yeah, it's 3/8 of an inch in. So that fully defined the sketch. We'll hit close. And now we just need to do that as a pocket, extruded here, symmetric to the plane, sketching plane, and through all. To go through all the way through on both sides, hit OK. And now we have our angled surface there on the front. So the next step here is we need to add that little boss up here on the front that sticks up a little bit. And it's kind of how would we create that? We need to extrude it, but we need it to just go until it hits that curved surface that we have right here. And I'm just going to pick that surface as my sketching plane. Hit create sketch. I'm going to just draw an arc in here. Not worry about the radius just yet. I'm going to draw a line, a horizontal line there. And I know that the center of my arc needs to be on the center line of the part. So we'll make those coincident. Let's take a look at the radius. It's an 11/16 radius, so we can apply that radius to the arc. 11/16. Okay. We gotta make sure that it's going to intersect the rest of the geometry, so we need to go back to our add existing geometry and pick this edge as a reference, and then that allows me to put this point on that edge. And now we're fully defined. Or are we? No, actually, no, we are not. So our FreeCAD's kind of lying to us here just a little bit. And this, because the center point of the arc is not defined height-wise. And actually, it's also telling us there's 1 degree of freedom still, and that would be the height of this. Now, on our drawing, it says here that that center, which is center of the hole and the center of this radius, are the same, and it's 2 3/16 of an inch up from this bottom edge. So we also need to add that bottom edge as reference geometry, and then we just do a vertical dimension from there to the center of 2.1875, and now it's fully constrained. So we can close the sketch, and now we just need to do an extruded pad. It needs to go the other direction. There's a couple ways you could do this. I could give it a dimension, because right now, if I look at this from the side, if I just extrude it like this dimension right here, you'll see that that does not intersect that curved surface. I could just increase this dimension to say 1 inch, and now it intersects it. And that's fine. We could say okay, and that gives us the shape that we want, the intersection of that surface and the curved surface. However, let's go back and edit that pad. That's not necessarily the cleanest way to do this, or I guess perhaps not the most elegant, because if this surface changes, the dimension you have to, or the distance you have to extrude that pad, you have to go back and update that to make sure that it's going to intersect. Now, the way that you can make the extrusion distance follow this surface is to tell it to extrude to first. And what it'll do is it will extrude to until it hits the first surface that it finds. And you can see here that in doing so, it automatically intersects them wherever this surface happens to be. So if I were to change my previous feature, change that radius or whatever, I don't have to come in and edit this pad in here, because it will automatically adjust the extrusion distance here, depending on where this surface happens to end up. So that just saves you a step. Doing it the other way with an actual dimension is fine, but it's just one more step that you have to remember to check. And I mean, I guess I could tell it to actually say extrude up to a face, and I could pick the far surface, and that would always ensure that it would intersect. I guess that's another way of doing it, but we're just going to tell it to go to where it intersects the first surface it encounters. So we'll say okay. And so now we have this little pad here. Let's make sure that we have refine turned on. Yeah, I guess it is. So I'm just going to go ahead and save it at this point. And then the next step with this is I am going to put this hole in here. And this is this is kind of a strange dimension, or a strange thread, not a very common. 13/16 is not a very common thread. But what I'm actually going to do is, see, we have a 3/4 inch bore, 1 3/16 deep with a flat bottom, and then you thread it 7/16 deep. So let's see here. Oh, okay. It doesn't go all the way through. All right. Noticing this dimension right here is less than this, and I thought it went all the way through. And that's because that bottom surface is where the end of the shaft is going to, or the screw will bottom out inside of there. Okay, so the first thing we'll do here is we'll actually make that bore. So again, we'll come in here and pick this surface, create a sketch. I'm going to use, because I want my hole to be centered on that arc. So we're going to pick the arc. So there I get the center point of the arc. And I can come in here and draw a circle. We'll give it a diameter dimension of 0.75. That fully constrains it because the center of my circle is tied to the center of that arc we had before, because they share the same center. And now let's do a pocket. 1.1875 inches deep. We'll say okay. And now we have our blind hole. And I'm not going to worry about the threads here at the moment. I haven't looked it up, but I'm going to say that likely the minor diameter of those threads is roughly 0.75 inches, which is why you would bore that first and then come back and add the threads in with no other machining operation. But we're just going to leave it with just the bore right now. And actually, I guess to follow suit with how I've been modeling things, I could actually just shoot for the middle of that tolerance, and I could come back and edit my sketch and make that 0.749. I don't think anyone's really going to care about that 1,000th of an inch, but for modeling purposes, but just to kind of stay consistent with how we've been modeling so far. I'll go ahead and do that. So we'll save it. Now, the next thing we have, there are a couple of holes here in the front face, a couple quarter inch holes. So we'll spin this around. I'll pick this face. Again, we're actually going to use the hole feature for this, but remember we have to create a sketch first to locate the holes. So we're going to create a sketch on the surface and draw a couple of circles here. They're going to be equal in diameter. They're going to be horizontal from each other, or the centers are horizontal with each other. I want to give them a diameter dimension of 0.25 inches. And this doesn't really matter for a whole feature. It's just using these circles to get their centers. And let's look at the dimensions. I believe it comes off of this edge of the jaw, and then there's a dimension between the two. So, right, so we're an inch up from this surface. We are 5/8 of an inch in from that edge, and then we're an inch and a half in between. So let's apply those three dimensions. First, let's make this edge a reference. So now I can apply a horizontal dimension from there to there, 65, and then I think it was 1.5 inches between, so 1.5, and then we can go an inch up from the bottom. And now our sketch is fully constrained, which is good. And so we can just hit close. And now I can I can select that sketch. I can come up here to the hole feature. And you'll see it's kind of showing me a preview here. This is I know it's a coarse thread. It's not isometric, it's imperial. So it's a coarse thread. The size is 1/4 inch. Let's see, can I choose the fit? No. Let's see, the hole depth. What was the hole depth? Oh, they don't tell you what the actual drilled hole depth is. Typically, it's in at least the imperial world, it's usually an eighth of an inch deeper than the actual thread depth. So that would be 3/4 of an inch deep on your tap drill hole, and then the threads being 5/8 of an inch deep. So let's come back over here, and the hole depth is going to be 0.75. It is there's no counterbore. It's threaded. Oh, there we go. I could actually set the class of the thread to be 3B for fit. And then the thread depth is an actual dimension of 0.65. And I'm not going to have the threads modeled. I could, and it would put the threads in there, but we're not going to do that. Just keep the model simple here. So say okay. So now we have those tapped holes in there. And then before I get into all the fillets and everything, there's actually a couple holes down here in the bottom. So let's go back and look at that. Let's look at the thread note here. So we have a number 25 drill, 1 1/16 deep, then a number 12, 24 thread, and then their counterboard here. So one thing I do know is that FreeCAD does not have number 12 threads. That's actually a fairly uncommon thread anymore. So I'm actually going to substitute a 1/4 inch thread for that, for this example. And I'm going to, or do I have to? I guess since they give me the diameter here, I could probably put that in as a custom thread. So let's see here. How can I do this? Well, the first thing I can do, I need to come here on the bottom surface and create a sketch. I want to just come in and create a couple of circles. Oops. I know that they're in line with each other vertically. We'll make them equal diameter. We'll give them a diameter dimension of 0.216. And then let's look at how they are dimensioned. It just says it's 5/8 of an inch between them, and then it's 1 3/16 from the back corner here over to the holes. Now, because they are only giving a dimension between the holes, I am going to assume that they are symmetric about the vertical axis. So in this particular case, I'm going to pick that point and this axis and make those symmetric. And then I need to pick this back edge as a reference. And then let's go back and look at our sketch. We just need a dimension between the holes here of 0.65. And then we need a horizontal dimension from here to this edge of 1.1875. All right, fully constrained. We close. So now we have our sketch there on the bottom. And now with that sketch selected, you can go back to the hole feature here. And I can actually make it a, see if I pick a fine thread. It's number 12. Oh, number 12 is in there. Oh, didn't see that before. All right, so we're in business here. So I can pick my number 12 thread, and it's a threaded hole. Let's go back and look at the note here. 2B, and it's only 3/4 of an inch deep. Okay. 12, 2B, hole depth. For this, the hole depth is for the tap drill, so that was 1.0625 inch and a 16th. My thread depth would be a dimension of 0.75. And then they did say that it is actually counterbored. And I'm going to make the counterbore was, I think, 730 seconds in diameter. So type in 730 seconds. And then the depth of the counterbore was, what did they say? 387" deep. Okay. So 0.375. Oh, I must have missed a 2 there. So it's making it 7/3, 730 seconds. Well, that's really interesting. FreeCAD is not letting me type in 730 seconds. All right, let's just say okay and see what happens. Oh, okay. I'm not sure why it didn't take it before, but we'll say okay now. All right, so you'll be able to see here, we have the counterbore in there, the tap drill hole. It intersects these slots just like it does in over here on the drawing, and which is correct. And I think that pretty much takes care of all of the major geometry, less the all of our fillets and rounds here. So let's just zoom back out. I want to turn off my axis or my planes and axes, all the reference geometry. And then let's just save this. And let's talk about how a strategy for doing all these radiuses. So one of the things that we currently do not have is we currently do not have a radius in this corner, and we also don't have a radius on these corners. And I guess because this outside radius here coming down and around and going around this turn and up and over is all, that's all an 1/8 of an inch consistent radius there. The only variations here are the 1/4 inch radiuses in this corner and the 1/4 inch radius on this corner. So one of the things we could do here is we could pick this edge, pick the fillet tool, make it a 0.25 inch radius. Oh, perfect. And then we'll pick pick this edge over here, and we'll say, okay, great. So now we have those two radiuses. And then if I pick this edge and make it a 0.25 inch radius. Now you'll notice here that what that does is it wants to select that entire edge there and go all the way around with a 1/4 inch radius all the way across that arc. And that isn't necessarily what they are saying here, or are they? I guess they are, because this radius is 1/4 of an inch in here. I guess it would be carried up and around there. So I guess maybe that is true. I was thinking maybe this might actually be an 1/8 of an inch radius up here, but we're just going to go with that. Again, a lot of these radiuses, unless that's just there for the casting purposes, so it's not really that critical. So we'll just say, okay. There is actually a way within FreeCAD, at least in the length stage branch, where I could make this radius variable. I can make it start as a 1/4 inch here and end as an 1/8 of an inch here, and then carry that 1/8 of an inch all the way across, and then go from 1/8 of an inch to a 1/4 of an inch over on that side. I don't think that's necessarily in the base or the main branch of FreeCAD, but so we're not going to mess with it here necessarily, but that would be an option if we really needed to do that. So I'm going to hit save. The next thing we want is we want to put a fillet on these corners. And the reason we'll do that is because if I fillet these corners, it'll create a continuous curve around this corner. So when I choose this edge to fillet it, that fillet will follow this curve, go around the corner and follow this curve up and around and continue all the way over till it gets over to here. You'll see here what I mean in a second. So we'll pick this edge first, make this a 0.125 radius. We'll pick this edge over here as well. Say okay. So now you can see we have a nice continuous curve there. And so if I pick this edge and also tell it to do the fillet, you'll see it's continued the fillet all the way across, all the way around, just like I had said. And so we'll make this 0.125 and hit okay. And I gotta say, that looks pretty good compared to the radiuses that they've shown here. The last thing I have not put in here is this radius in here, and so we're gonna do that last. And that's this corner in here. I'm gonna select that edge, hit fillet, and make it a 0.125 radius. Say okay. And I do believe that that is our jaw, our sliding jaw, as they have it shown here. So we're just going to save this, and I'm actually going to close that file, and we're going to create a new file. And now let's tackle the base up here. Now let's see, how could I do this? One way I could see doing this is looking at it from the side. We could draw this entire profile here down. We're going to ignore the ears over here on the side. Come down and go all the way back. We could take that, extrude it the full width, and then we could come in and we could add this little hump up here on top. And then cut the slot all the way through, and then add these ears on out here with their holes. And this is symmetric about the center line because they have kind of show the ears a little bit hidden over here on the other side. So we may be able to use some mirror commands and stuff here, but just kind of trying to break this down into some manageable pieces. So I mean, I could technically just draw a big rectangle, or even draw this end profile minus the ears and extend it up higher than it needs to be and extrude it the full length. That would be another way, and then come in and cut this off. But I think that just drawing this side profile and extruding it symmetric to the center line here is going to be the best way to do this. So let's go in and we're going to create a part again. Oops. Create a body within the part. And let's just rename this to be, I think that's item 1. Yes, item 1 is the base. So we're just going to rename this 1-base. And then let's save our file and call it 1-space-base. Turn on our datum planes, and I think I'm going to let the very bottom surface of this be the XY plane, and then I want to make the XZ plane kind of be our plane of symmetry along this axis. So let's just come in here on our XZ plane, create a sketch, and go back to the part here. I'm just going to use this back surface as the end of the part. I guess I technically could probably use maybe this corner here as the vertical axis. It doesn't necessarily matter. Maybe we will. That might actually, just to show that we can do it. So let's draw the general shape of this. So again, I like to usually draw things off of the planes or axes, like make them disconnected initially and then come back and connect them up later. Oops. Oh, I accidentally escaped out of my sketch. I'll go back and edit the sketch here. All right, so we just want to create a line from there to there. I know that there is an arc between those 2 points. I don't know the radius, but all right, we'll just kind of drag this over. Well, we know we want this point to be on this line, so we'll do coincident. This is going to be on that one. And, ooh, I actually didn't draw this correctly down here. I forgot to add the extra hump. But that's easily fixed. We can just come in here and draw 2 lines. I'm actually going to make that coincident there. And now I can come in here and trim this. Trim that out. And now I can make these 2 coincident. Oops, they must not be close enough. Oh, there we go. Sometimes FreeCAD will do that. Like you apply and it says that it can't do it, but then you go and try to drag the point to make them closer and then they snap right to each other. So it's a minor thing. Let's look at some dimensions here. So the height up to this surface is 2 3/16. The height to this is 1 9/16. We have a thickness here. And I don't think we, oh yeah, we do have an overall length here of 7 1/4. So let's just apply a few dimensions here. So we know that we have, this is 7.25. And FreeCAD will scale everything up based on the dimensions you type in. Sometimes they can make your model go a little wonky here, but we just have to drag a few things back, make it look a little more proportional. We know that there's a dimension from here to here that's 1.25. I know that there was a vertical dimension for this. It was like 2 9/16, I think. Let's go back and look. 2 3/16. Okay. And then it's 5 inches from that face over to this one. So we'll just apply a horizontal dimension here of 5 inches. Drag that up a little bit. Apply a vertical dimension from here to here of, that was 1.5625, right? Yes. Then the height of the jaw here is 1.75. So we'll apply a vertical dimension there of 1.75. And let's look at our arc out here. We need to probably know where its center is, and then I'm not sure if it's actually tangent to the end. Oh, it actually is tangent to the end, which makes it convenient. So we can just pick this arc and this line and make them tangent to each other. Here's my tangency. Again, there was a redundant constraint that was removed there by me applying that tangency. It removed, I think, a coincident constraint right there that became redundant when I did that. So it was nice. And then I think the radius of the arc was 1.375. And let's see here. What is, oh, the center of my arc, the vertical dimension's not set. And I know it came down from the top. I just don't remember what it was. So let's just put the dimension on here. That's probably actually pretty close, but let's just double check. Yeah, that was pretty close. Eyeballing it, 1.1875. All right, so now we are fully constrained. So let's hit close, back off here a little bit. And so now we just need to pad this, do an extruded pad here. How wide is it? 2.75. So we'll just pick our sketch, do a pad, symmetric to the plane of 2.75. And there we are. So we'll save it right here. The next thing I'll do is I'll come down here and add this the little hump down here on this end. So let's just pick our end plane here, create a sketch. Like we did on the last one, we want to have that edge as a reference. So I need to add external geometry and pick that top edge. And then we can come in here and draw an arc. Draw a line between those 2 points. We'll make it horizontal. Now we just need this point to be on that line. And we know that our arc center is on the vertical axis. I'm just going to drag this down because I know the center is below. Let's figure out what the radius is and apply it. So we'll just put a radius on there that we're going to change here in a second. So now it's something bigger than that. That radius is 11/16, and it is 2¼ inches up from the bottom. So we're going to put a vertical dimension on here from the center down to the bottom of 2.25. And then that radius was 11/16. Okay. All right, so we're fully constrained, we're closed. Now we just need to pad that. And I want to tell it to come up to a face, and I'm going to choose this face right here. Because if this face changes, I want the end of that to follow that with it. I could have just figured out what this dimension was, and I could have done it extruded by a dimension, but then again, you have to go back and update that if you change this dimension. And I'd rather not have to update multiple dimensions if that face should follow, if my design intent is that that face should follow the face of the internal surface here. So if it's supposed to follow it, you should make it follow it along with it, or do it automatically. It just saves you forgetting to update that dimension if you made it extruded by a dimension. It's an easy mistake to make, an easy thing to forget to do. So we're just going to hit OK. And now the next thing I want to do is I'm actually going to add these ears to the outside here. So let's just save this. Guess what I could do here, there's a couple ways I could do this. I could pick my XY plane as my sketch plane and do this, or I could actually pick this bottom surface as my sketch plane. I'm just going to go with the XY plane for now and say sketch. And now I know that these ears are an arc here of 1 1/8" radius. They're tangent to the end of the part, and it also appears as though the center of the radius falls right on this vertical surface. So because they don't give you a dimension, say from that surface out to the center of that arc. So to assume that they're in that same, the center is in that same plane is probably fair to do. So so what I'm going to do is I want to draw one side, and then I'm going to mirror it across to the other side. And so let's see here. I want this bottom edge to be my reference. And that should be all I really need, actually. So let's come in here and let's draw an arc here. We'll draw an arc down here as well. Now we'll draw a line from there to there, and then one from there to there. And I know that the center of this is going to fall on this line, which means that these 2 points will be directly across from each other. So I can put this point on this line, and I could put this point on this line. And then I know that these two are equal in radius, so we'll just make them equal. And then I'm going to give that radius, I think it was 1.125. And then the last thing I really need to do is put this point on here and put this point on here. And now that's fully constrained. And another thing I could actually do here, if I really wanted to, is I could put these holes in here in this feature as well. So let's see here. What size are those holes? 15, 6, or 5/16. Okay. And they are 4 inches center to center across the part. So they'll be 2 inches off the center line. So we'll actually just come in here and draw 2 circles. I'll draw a circle there and a circle here. These 2 circles are equal to each other. I know that the center of that is in line with the center of my ear. We'll do the same thing over here. I also know that these 2 are the same distance out from the center line, so it'll be a horizontal constraint there. We'll apply a diameter constraint here of 5/16. And then the last thing we need is the dimension out from there to there of 2 inches. And that should be everything fully constrained. Yep. All right, so we'll hit close. And then the last thing I need to do is extrude that up, and I don't know how thick it was. Well, it's 5/16, 7-inch thick. Okay. So we'll pick our sketch, we'll pad it 5/16. Say okay. And that's looking pretty good. Now the next thing I could do is I could take this pad and select it and do a mirror. But that's not the correct mirror plane. We actually want, let's see, what plane is that? That it would be the XZ plane. Is the center line again? Yeah, so we could pick the XZ plane. And now you see it's a mirror image to the other side, which is what we want. And we only have that pad selected to mirror, so we'll say okay, and boom, now we have those ears on the other side, which is good. All right, the next thing we'll do is we want to put that cut through, this cut out through the center. I know it's the same all the way through, so I could actually come over here. I could choose this plane to be my sketch plane, but I can also just pick our base YZ plane here to sketch on and extrude it symmetrically through all, and that will achieve the same result. And it kind of helps deal with that some of the issues of the topological naming problem of referencing other surfaces. If you tie it to this plane, it won't be quite the problem. So we'll just pick that plane, create a sketch, and we're going to come in here and just draw our general shape. So there, 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 there. And then I know that these points are symmetric. Actually, we'll make this a little bit easier on ourselves. We'll say this point and this point are symmetric. And then we'll say this point and, well, actually, no, we can just say these two are equal to each other. That takes care of symmetry for these points and these points. That they're automatically going to be symmetric because I made these 2 points symmetric. We have the vertical constraints here. It helps minimize the number of constraints, and the fewer constraints you have overall, the better. And that doesn't matter. It's not just a FreeCAD thing. That's an overall 3D CAD practice. You want the minimum number of dimensions and the minimum number of constraints overall to have to worry about. In fact, you would prefer that you use geometric constraints over actual dimensions to define your geometry. If things truly are symmetric, you should make them symmetric. You don't. I could have actually dimensioned every single edge in this, and I've seen people do that, and it creates a nightmare down the road when you have to modify your part. It's so hard to know. And you also have a whole bunch of dimensions to edit just to make a minor change. And so let's look at our drawing here and see how it's dimensioned. So we're given a width here, and we're given a width here, and then we're also given a height here, and we're given an overall height there. So, all right, let's define this. We have this dimension. We have a dimension from the bottom all the way to the top. And you'll notice I did not tie this to the bottom yet. I don't have to right away. We can always do it later. I know this dimension is given, and also this dimension is given. I'm not worrying about them right now, but then we just need to put this point on this bottom plane. And you'll notice it says it's fully constrained, but the dimensions here are not correct. But that's okay. We can enter them in right now. This is a good way also, if you're creating a new design and you don't know quite what your dimensions are actually going to be, you can just throw random numbers in here just to define it, and then come back later, and when you actually do know the number, you can just type it in and your geometry is already there and it's already defined how it's supposed to be. You're just massaging the numbers per your design requirements. So let's actually fix this. So the width of the upper part, the average there is 1.002. For the bottom, oh, forgive my errant right clicks here, 1.252 for that one. All right, so then we have our vertical dimensions here, which are 11/16 and 1 11/16. Okay, so we'll just edit the upper one first, 0.6875, and then this one is 0.6875. And now it's fully constrained, all the dimensions are correct, and we'll just say close. So now, all we really need to do, let's do a pocket through all, symmetric to our sketching plane. Hit OK. And now we have that pocket all the way through the part, which is good. So we'll save this. I'll clear my console there. All right, next features would be, let's just put these holes in down here, and they are 1/4 holes. So we'll use the hole feature. Again, they don't tell you the tap drill depth, but I'm assuming that it's 1/8 of an inch deeper than the actual thread depth. So like we did before, we'll pick this surface, we'll create a sketch. We'll come in here and draw a couple of circles. And we'll make them equal to each other. We'll make them 1/4 of an inch in diameter to match our thread size. Again, numbers here don't really matter so much as the technique. I said, pretend this is a 1/25th scale Vise if you want to convert everything to make all these millimeters, or take all these and multiply them times 25 to have your metric equivalent. So let's see. And in reality, I will bet you that these holes are actually symmetric about the center line, but that's not how it's actually dimensioned. That would be making an assumption. So they're saying to come off of this side over here. So that's what we'll do for ours. So we know that these two are horizontal with each other. So we'll make them horizontal. I'm going to pick this side edge as a reference edge using add external geometry. Now let's go back and view our sketch. We'll add a horizontal dimension from here to here, and I think that was 0.65. Then I think it was 1.5 between them. Let's take a look. Yes, 1.5 between them, and then they are 1 inch up from that, from this surface here. So let's come back over. Well, the end of that line coincides with this surface, so now we can just apply a vertical dimension from this point up to here of 1 inch. So that fully constrains my sketch, so I can close this. And then now with that sketch selected, I can come up here to my hole feature. It is a coarse thread. It's a threaded hole. It's a 1/4 inch to be. The thread depth is 0.65. Our hole depth, or the hole depth is going to be 0.75. And I want the thread to be a specific dimension of 0.65 deep. And we'll say okay. So now we have those two holes over there. If I view this as with hidden lines here, you'll be able to see, oh boy, maybe you aren't able to see very well. Let's go to wireframe. You'll see those drilled holes over there going back into that part of the part. I think I need to adjust my colors in FreeCAD here to make it a little easier to see some things. So let's just save this. The next thing we'll do is we'll put the hole through over on this end, and that's the hole for the Acme thread. And again, I'm not going to put the actual Acme threads in here today. Yeah, it's a 5/8 Acme. So I know the diameter is actually smaller than 5/8. I could go look up what the minor diameter for a 5/8 Acme thread is, but we're just going to make it, for our purposes here, we're just going to make it a 5/8 through hole. And there it'll go all the way through here. So we'll come in here and pick this end surface, create a sketch. We want our hole to be at the center of that arc, so we'll reference this arc. And we're just going to draw a circle with diameter 0.625. I could always come back and make this smaller in the future if I wanted to, but if I actually put the actual thread in there. So we can, since we're fully constrained, we'll say close. Now we'll just pocket that. And here we can actually say up to first. And again, what this will do is you can see it's stopping at the first surface that it runs into there. And that's what we want. If this surface moves, we want our hole to follow it. So we'll say okay. And so now that is in there. And I think, yes, that is everything on the major geometry. The last thing we have to do here is apply all these fillets and rounds. So some of them are 1/4 inch, some of them are 1/8 inch on the smaller ones. So what we'll do here, I'm actually just going to turn the planes off. We'll save it. Let's just do some of these 1/4 inch ones. Actually a 1/4 inch radius up here as well. So we'll just pick this edge to start with, and we'll make that a 0.25 radius. And we'll do this one over here, this edge over here. I'm not zoomed in far enough. Pick that. I know that this one's a 1/4 inch radius. That one's a 1/4 inch radius. This edge and this edge. I think that's all of them. Except for these right here, which we'll do those next. If I hadn't done this inside radius here first, FreeCAD would have difficulty trying to get this this edge filleted to where it comes out and intersects nicely with this in this corner here. You'll see what I mean in a second. So we'll just say okay. And so now we have all of those fillets on there. Now I can pick this edge right here, do a fillet, again, make it 0.25. Ooh. FreeCAD is telling me that that fillet is going to be invalid over there. Or result in an invalid shape. And you can kind of see what's going on there in that the fillet wants to overhang a little bit on this side. Presents a bit of a conundrum. So how could we tackle this? Because if I try to say okay right now, it's showing a fillet, but that's really incorrect right there. And this is a problem that you'll run into in 3D modeling for sure. Because if you're the mold maker making this mold, you would just blend that sort of by hand in there. So how can we combat this? Let's delete the fillet. And if I choose, let's say, choose this edge and say fillet. All right, so it's going to apply a fillet along that edge, which is something that we want, and that's going to be a 0.125 radius. So we can say, okay. So if we do that first, now if I choose this edge and apply a 0.25 inch radius, it cannot do that. Around that corner, you can see it's trying right there. This may actually be a situation where we have to, again, this is something where the length stage branch is actually really convenient because we can do variable radiuses here. So if I were to go in and pick this edge also, I can come in here and add two parameters to this edge where I can make the start radius full size and the end radius 0. So I can send this to 0. If I send that to 0, and make that 0.25. Is that going to work? Maybe I have these opposite. Boy, it really does not like that. Let's make the radius something like a really small value, like 0.001. Okay, so that means if I say 0.25 for my total radius, and I make this one also 0.25, see what FreeCAD does with that. Boy, that's really not how that's supposed to be. Wow. Okay. Again, this is good stuff here because it shows you the kind of problems you run into trying to model some of this stuff. So if I just delete that fillet, I choose this edge. Let's try one other thing here. Sometimes the part design fillet tool doesn't work the best. Because, and there are limitations there, but there's a fillet tool in the part workbench. So let's switch over to part. We have that edge selected. I can choose, where is, oh, here it is. There's the fillet command here. And it says you're doing a non-part design command on a part design body, and we could try to do it with the part design command that's equivalent, and that's not what we're trying to do here. So we'll say no, and I'm just going to pick that edge, and I'm going to give it, let's see, can I define the radius? Yeah, 0.25. So if I define that radius, it should see what it gives me. Ooh, boy. I don't think that really solved it either here. Let's take a look at this. On wireframe. Or possibly just shaded. Yeah, it's really not liking that intersection there. So, all right. Back to troubleshooting. So we'll get rid of that fillet. We'll come back and do what we did before. And that is, we'll pick this edge, come back in part design. We'll make it filleted to 0.125. And then now we can pick this edge again. And let's try to do this with the part workbench again. And let's see what it does. Well, that also failed, so it made it actually worse. So we'll delete that. Boy, I'm going to have to think on this one a little bit harder, I think. But the one thing I will say here is we can get it pretty close to the finished part by coming in, and we'll select some of the other edges that we know our 1/8 inch radiuses, like this one and this one, and say okay. Switch back to part design. I just was editing that part design fillet there. Let's see here. So now that means I can go in here and apply a fillet around this of 0.125 all the way around there. And that takes care of that end, takes care of that radius. Yeah, so the real struggle that we have here is getting these to intersect. And I guess one way that this could be approached would be to do these ears separately as their own body and fillet them separately, and then combine the two bodies together in the end. That might be a way to approach it, but I'm going to have to play around with this a little bit more, I think, on my own to try to figure out the best strategy to try to solve that radius problem. I don't think that just picking, say, this edge and telling it to fillet that to 0.125. Yeah, it's too big of a radius. It doesn't know how to deal with that. Try smaller radiuses. Nope, not going to work. So yeah, that's something I'm going to have to reference on my own and try to see if I can come up with a good strategy for that. But doing it here on the stream, that's a real brain teaser for how to get FreeCAD to put that in there. It's like I said, it's difficult. Some of these radiuses and things in here are really kind of tough to get them to blend together properly the way that it's shown. So I'm going to leave that to perhaps another stream in the future after I have a chance to play around with it here. And then that should pretty much do all of the parts. I guess the only thing I haven't done is this this slide key. Let's just do that real quick. So close, or save it. We'll close that, create a new part, or a new file, create a part, create a body in the part. And let's see, what number was that? Number 9. Okay, so let's rename this to 9-slide key. And we'll save the file as 9-slide key. All right, turn on our planes. This one, it's not super critical which surfaces you start with, but it's a relatively symmetric part, so I could actually just draw this side profile, extrude it, and be done. So we're just going to pick the XC plane, sketch. We'll draw our rough profile here. I know this is a very simple part, but yeah, so we'll just put this point on that plane, this point on that plane. Let's look at the overall dimensions here. So we have a dimension from that end, the width, an overall length, and overall height. So let's just give it an overall length, give it that dimension, the width of the slot. Then we have the height of the overall piece, and then we'll just have the height of that. I think that was 1/8 of an inch. So we'll just start with that. These are a little messy here. And then the other thing I'm going to do here is I'm just going to drag this over and put this point at the origin. I don't know if that really matters. Must not have picked the point. Okay. So let's see. The overall length was 2 and 5/16. So 2.3125. I think this was 1 and a 32nd, maybe. And then the width of the slot is 5/32. Oh, this was 1 and 3/32. So 1.09375. I shouldn't know things like that. 16ths wide slot. And we'll say close. Now we can pad this symmetric to the plane. I think it was 0.1875, maybe. Let's take a look. 0.1855. Okay. And that is your slide key. So we'll save that. And now I do believe that I have modeled all of the parts of the vise here. And so I guess what I'm going to do is I'm going to have to research this again, like I said, to try to figure out the best strategy for trying to get these radiuses to blend together on this base here. And then maybe in the next stream, we'll have a good solution for that. And then also I will have, or possibly go through some of the assembly procedure for using assembly 3 to put all of these parts we've created together to create the assembly you see up here in the corner. So I hope this was helpful for you. And if you have any questions, just drop a comment. You can hit me up on Mastodon. It's at chrishuck@fosstodon.org. You can shoot me questions there. And thanks for watching, and we'll see you in the next stream.